A rock of mass 2 kilograms is launched vertically upward with an initial speed of 60 meters per second from ground level, and air resistance is negligible. So in part A, we want to draw the free body diagrams for the rock at 3 different points in its motion: on the way up, at the top, and on the way down. So on the way up, and at the top, and on the way down, it has a gravitational force. So we'll go ahead and put this on all 3 of them. And the gravitational force is always downward, and it's the same value for all 3 of them. And because air resistance is negligible, that means there's going to be no drag force. And because the rock is in free fall, that means there's no other forces on there. So for all 3 free body diagrams, it is the exact same figure, which is just one downward force, the gravitational force. And this is a common thing they do in the AP exam. They'll give you multiple free body diagrams with different sounding situations, and a lot of students think that you want to draw different diagrams on each, but oftentimes they do end up all being the same diagram. Part B briefly explains what happens to the magnitude and direction of the net force on the rock from the moment it's released until just before it hits the ground. Well, since the net force is the same in each case, the net force in the y direction, it should be a y, is just equal to the gravitational force, which is m times g. Mass is 20, g is 10. So the net force is always 20 newtons, and it's always pointing in the downward direction. So to briefly explain, you can just say that it's the same magnitude of 20 newtons the entire time, and it's the same downward direction the entire time. Part C, calculate the maximum height above ground level the rock reaches. Okay, we're getting into kinematics now. So let's look at what we know for this problem. You're given the initial velocity. It says the rock was launched at 60 meters per second. And we know that the acceleration of an object in free fall is 10 meters per second squared. And because this rock was launched upward, we're going to use up as the positive direction, down as the negative direction, which is why we're including the negative sign on there, since the acceleration of gravity is downward. And we also know that at the highest point, as the rock is going up, coming to the highest point, the velocity at the highest point is equal to 0. And at that point, we can calculate the maximum height, the delta y. So t is missing, so we're going to use the last kinematics equation, v squared equals vo squared plus 2a delta y. Let's go through the normal 3-step process. First step is anything that's equal to 0, get rid of it. So v squared is 0. We now have 0 equals vo squared plus 2a delta y. Next step is to rearrange the equation for whatever it is we're looking for, which in this case is the delta y. So to get delta y by itself, we're going to bring the vo squared to the other side by subtracting it. So negative vo squared equals 2a delta y, and then just divide both sides of the equation by the 2a. So the 2's and the a's will cancel out. So we now have the equation delta y is equal to negative vo squared divided by 2a, and we can plug in negative 60 squared over 2 times negative 10. Notice that the negative in the numerator and the denominator will cancel out. You end up with 3,600 divided by 20, which gives you a final answer of 180 meters. Part D, as the rock is moving upward, will its speed be equal to half of its initial speed? Remember, the initial speed was 60 meters per second, so half of the initial speed is 30 meters per second. So it's saying, will the speed of the rock be 30 meters per second when it is halfway to the maximum height, So if we look at this arrow I drew earlier, halfway to the maximum height, is the speed going to be 30 meters per second right here? Is it going to be a little bit more than halfway, like somewhere up here? Or is it going to be less than halfway, like somewhere down here? Now, it's tempting for people to just say that because it's halfway to its maximum height, it's going to have half the speed. But what you got to watch out for is the fact that the distance and the velocities are connected, but the velocity is squared. So it's not a direct linear relationship. So it's actually not going to be at the halfway point. So I'll mention the answer for this one two different ways. One is just kind of like thinking about it without using any numbers at all. And then the other way is just solving it with the numbers. And that is that, so the first way, without using any numbers, is to just think about that with this upward arrow, with it starting at 60 meters per second and ending at the top at 0, the halfway speed is 30 meters per second. So that means from here to the 30 meters per second mark, it's got to move a certain time, and then from 30 meters per second to 0 meters per second, it's got to move for a certain time for a certain distance. And the average speed is much greater as it's going from 60 to 30 than as it's going from 30 to 0. So because the average speed is greater from 60 to 30, it's going to move more of a distance during that time than it will move as it goes from 30 to 0. So the 30 meters per second actually occurs a little bit more than the halfway point. You can also do this just purely mathematically, since it doesn't say to justify the answer without calculations. You could basically treat this the same way we just did part C, the only difference being instead of VO being equal to 0, we could just say, instead of V being equal to 0, we could say the final velocity. Where does it actually reach the final speed of 30 meters per second? But everything else, keep it the same. So using the same equation, the one from up here, if we take that equation, the V is not going to be equal to 0 now, so we're not going to get rid of that. The V will be equal to 30. So let's just rearrange this equation without plugging in a 0. That gives you V squared minus VO squared is equal to 2A delta Y, and then divide both sides by the 2A so that the 2's and the A's cancel, and get all the numbers plugged in. So delta Y is equal to V squared, that's 30 squared, minus VO squared, that's 60 squared, divided by 2 times negative 10. And with all these numbers plugged in, you'll get an answer of 135 meters. And if you compare that to this, well, if 180 meters is the total height, the halfway point is 90 meters. So this is quite a bit above that halfway point. And for part E, if you are asked to calculate how long it takes the rock to reach a height of 100 meters, you could use the kinematics equation delta Y is equal to VOT plus 1/2 AT squared. And instead of rearranging this one, instead of doing the normal three-step process, because the first thing is that nothing in this equation is equal to 0, so the first step's gone. But the second thing is, this is not an equation that you can just rearrange very simply to get the t by itself, because we have a t here and we have a t squared here. Most of the times we've had an initial velocity of 0, so this whole term has gone away. So then it's really easy to solve for the t. But this one, because we have a t in two separate places and nothing going to 0, it's actually easier. This is one of the rare exceptions where it's better to plug the numbers in first. So we have the 100 is equal to, and we said the initial velocity is 60, so we have 60t, plus 1/2 times a, which is negative 10, so that's negative 5, so we'll put minus 5t squared. And because it has that t in two separate places, one which is just a t, and then one which is the t squared, this is a quadratic equation. And you remember with the quadratic formula that you use to solve a quadratic equation, you always end up with two solutions, So even though you're never going to be asked to solve a quadratic problem on the test, you are going to be asked to be able to recognize them and understand why they have multiple solutions. And in this case, it has two solutions because if we just said earlier that the rock goes to a height of 180 meters, so let's say this arrow is going up to 180 meters, that means 100 meters is about right here, and it's got to pass that height on the way up, but also on the way down. So it reaches the height of 100 meters at two separate times, and that's why you have two possible answers to the quadratic formula.